Hello, this is Harshit and this is a report on the first assignment of Signal Systems Laboratory where we will discuss MATLAB Basics. The first part is basic semantic operations. Now we'll see the MATLAB command for that. So this was 5, and to create a simple vector A with 10 elements we just define A equals to in column brackets 1 comma 1 colon 10 to create elements with the increment of unity as this 1 2 3 4 5 6 7 8 9 10. Now to add 3 to each element we just define b equals to a plus 3 which adds 3 to each element. Now to create a 5 plus 5 matrix x from that we can use the command x equals to 1 colon 5 semicolon. 1 colon 5 creates a particular row as 1 2 3 4 5 and the semicolon moves it to the next row, and where we can use 6 colon 10, and similarly we get a 5 plus 5 matrix x as this. To find the transpose of matrix x we can use the command y equals to x dash which gives us this. To multiply these two matrices we write x into y and we get our answer as this. Now to multiply these elements, these two matrices element wise, we use x dot into y, which gives us the element wise property of the matrices. Now to create a particular column vector x1 from the elements of fourth row matrix x, we use x1 equals to x 4 comma colon. This gives us the entire fourth row, and we take the transpose of that so that we get a column vector as this. Now to select the element in the nth column of the matrix x, we use c equals to x colon 3 4. This selects all the row elements in the columns 3 and 4 and we get this. Now to get a submatrix x for the inner subpart we use a similar command x 2 colon 4 comma 2 colon 4 to get the elements corresponding to the second, third, fourth row and column as this. Now to read a particular row, for example the third column or third row, we can use x colon comma column number equals to blank column brackets to delete that column, and we get this with the third column deleted. And to delete a row we can use x row number comma colon and equals to square blank square bracket which delete the third row as this. Now we will move to the second part of our assignment, which is the MATLAB commands graph, save and read. Now the code for that is this. Here we will generate elementary signals and display them using plot and subplot commands. For that we first create our matrix T with elements from -5 to 5 with the increment of 0.01, and we declare a similar unit step variable with zeros for all t, and which we change to 1 for all t greater than equals 0. And now we divide our plot scheme into 4 parts in the subplot function. We use the x label as t, y label as f of t, and we get the grid on and x is typed. And we plot the t and comma unit step in blue color with the lines of 2, and we give a title to our plot as subplot 1 unit step function. Now for the second part of our plot scheme, we use the subplot 2 to 2. We use the second part of our plot scheme. Now we use similarly we define a variable exponential to calculate exponent using exp command, which is in MATLAB, and we declare similar labels and we plot t exponential in blue color and line with 2, and we give a title to that also exponential function. Now for the next part of our plot scheme we use sinusoidal functions, and we use the subplot from command 2 2 3 4 which is the entire remaining area, and we use define t in the similarly, and we use labels and we plot t sine t in blue color line with 2, and we use the hold on command to keep our sine function as we plot cosine function over that, and to differentiate between them we use legends at sine t and cos t, and we give a title to that as subplot t sine function. This is the plot which we get. The first part is subplot 1 is unit step function, subplot 2 exponential function, subplot 3 sinusoidal function. Now so moving on, now we will see save, load, accelerate, read, accelerate, write, and order read and order write commands. For that first we create two variables a and b, and now we save them into a file named abfile.mat, and the variables have to pass as a and b, which are to be saved. This will create a file abfile.mat, which is this. Now we can also similarly save them into a text file or Excel file using the extension txt and xls, and we also pass -sky so that it is readable to us. Similarly we can declare two more variables if 97 equals 98, and we save them into a next file abc, which by default is a mat file, and we will give the master case so that we can read them. And to read, we use the type command, type abc, which shows our file, which contains the variables 97, 98 as a and b, and the files can be seen here as ab1 file.txt, ab1 file.xls, and abc.mat. And we can also open Notepad. For that, we can also display them in a Notepad file using the command system notepad and the address of the file, which show them in a Notepad. Now, to create a structure, we use the struct keyword, and we define the fields as a, b, and c, and the values are 5, 10, and 15. Now, we can save this into a new struct.mat file using the keyword -struct, and we have to get a variable name and the fields abc which to be stored, and this saves them into a file, this new struct.mat. Now we save a and b once more in a new file example, and we append c equals to 3 into that. For that, we use a general save command with a keyword at end is -append, which appends c to the original file example. Now, to read cell and write cell commands, we first define a variable x to contain our data, which is this, which you can see here. Here is our x matrix which we create, and now we can write it into a data.xls file, this, and we can read the file using the read cell command and the file name, and which gives us the file. Now we can also similarly write a matrix using read matrix and write matrix command. For that, first we generate a random array 5 cross 5 using the rand keyword, and we write that into datamat.xls file, which is this, and we can read the file datamat.xls. So this was our matrix which is stored, and this is the answer which is secure, and we read that. Now to read audio files, we use load handle.mat, and we use the file name. We give the file name handle.wab. Now this is a predefined audio in a MATLAB, and we write the audio as in file name y,fs using the and we clear yfs, and we read, and we use the audio read command handle to read the file handle.web, and to play the audio we can use the sound yfs command, and similarly we can save it into a ogg file. Now you can hear the audio as I will play it now. Now moving on to our third subpart, which is writing expressions. Which is this. To write expressions, we first construct a symbolic variable x, in terms of which we will define our equation, and we define its coefficients as to solve the equation, and we can use this, and we get a plot. For that, we will see later, and we get our roots as this. Now to plot that, similarly we can create a matrix x with -5 to 10 and plot and define function f equals to x square plus 0.5x plus 2, and plot x comma x in blue color with line width 2, and use the labels h, y, and grid on, and give a title, and which will give us a plot as this. Moving on, now we'll see MATLAB commands for create, combine, and manipulation of arrays. So here is a part that, so first we use the repeat element command, which repeats the element 4 times. So here is our matrix A. Now we can use a repeat match to repeat the entire matrix, which is the we repeat the matrix A 4 times using the repeat command, and which gives us B is this. Now we can get an identity matrix of size 4 cross 4 using the I command, which gives us this. Now we can create a completely zero array using zeros command, and we get our O matrix of this. Now we can create a matrix with all ones, and we get this. Now to create a random matrix, we use the rand command, and we can use a reshape command to reshape our array. remember the array A, which was a single row with elements 2, 2, 2, 2, and now we are changing its dimension to 2 cross 2, and we get the new array D as this. Now we can concatenate arrays using the cat command, and we pass E equals to cat 3 C, and the matrix is O. So it creates a 3-dimensional array which we get as this using the concatenation of the matrices C and O. Now we can use the to concatenate the arrays horizontally. We can use F in square bracket C comma O, which concatenate them horizontally, and vertically we can use a semicolon between them. To create a diagonal matrix, we use a die command which gives us which creates a diagonal matrix with the elements of A, which was a array initially, which gives a 2, 2, 2, 2, and we get this. Now we can get the diagonal elements of a random matrix R, which we created above using the die command similarly, and we get this. Now we can use block diagonal matrix command to get our block diagonal, and we get this, which is just array A repeated as all. This is the array A which is repeated here, here, and here. And we can use flip LR, flip UD to flip a matrix from left to right and up to down, and we flip our random matrix, so we get KL as this. Now we can use a rot 90 to rotate it counterclockwise 9 by 99 degree, and we get M as this. And we can extract the lower triangular part using a trill command, then the upper triangular part using a triu command, TRIU, for the upper triangular part. Now to permute, we can change the dimension as which was initially something else, and we change it to 3 cross 1 cross 2, and we get our new matrix Q as this, which is a 3-dimensional matrix. And we can circularly shift our random matrix by 3 positions using a shift command, and we get this. And if we can find the length of our matrix by using the length command, which gives us 5. This gives the length of the maximum size, and we can use the size command as z size r to get the size of our matrix, and we can get a dimension using a ndims command, the number of dimension which is 2, and we can use the numeral number of array elements command to get the number of elements, and we can find if it's empty using the isEmpty command. Moving on to the next part of our assignment, now we'll see the loop types in MATLAB. So here is our MATLAB command, and there's different loops, and first we use the while loop. For that we declare variable I equals to 1, and we use the while loop I equals to 2. So this repeats this statement until the condition becomes false, and we get an output at this while loop which executes 2 times. Similarly, we can use the nested while loop for while inside the while, and which gives us this. For the inner loop is executed and the outer loop is executed. Similarly, the for loop can be seen for which repeats the body of the element body of the loop a particular times as defined by the variable I, and we can use a nested for loop for that. Now there are 2 loop control functions with the keywords continue and break, which you can use. Continue is used to skip the next part, remaining body of the loop, and break is used to get out of the loop, and we can use them as like this. For I greater than 2 and I greater than 9, which it will skip. So this will print the values for values of I as 1, 2, and 10, 1 to 9 and 10, and we get this whole 9. And similarly, if we use break command, we use if I greater than 2 break, which comes out of the loop as soon as I equals to 2, and we get 2 lines of our code as this. Now moving on to the last part of our assignment, we'll see the decision making statements in MATLAB. So here are the decision making statements in MATLAB. First is the if statement. We first define a variable if, and it simply checks the condition. If the condition is true, it executes the next command which are in the part of it, and we use end keyword to end the if command. We can also use the if else command, where if this condition is not true, we can have alternate situation. So this part is executed, but if this condition is true, then this part is executed and this part is skipped. We can see that As for the first part, we see I is greater than 0 as I equals to 2 is true, so we get this output as I is greater than 0 as this. Similarly, for the next part, we get I is not 3 as this condition is false. We can also use if else if command if we have multiple conditions to check, so that we first define one if condition, then next else if condition, next else if condition. So which condition is true, that will be executed. If this condition is true, this part is executed. But if it is false, so we'll check this condition, and if it is true, this part is executed. Similarly, if this condition is true, this part is executed. But if condition is false, we move to else part. This part will be executed. Here as I was 2, so we get this line as I equals to 2. Now we see nested if condition. We first check for if I is greater than 0. As it is greater than 0, we move to the next part. If I equals to 2, it displays I is 2 as we get this. But if this condition is false, then we move to this part and we get out of the loop. Now we see switch statement matrix. Now we use a variable switch, and we define similar cases depending on the value of this. So first we will get the value of switch I. So I is 2, so case 2 will be executed. Case 1 will not be executed, and case 3 will also not be executed. Only case 1 will be executed. So as we get I equals to 2 using the case 1 command. And if we want to get the default value of I, if none of the cases are true, then we can use the otherwise command. Similarly, we can use nested switch to use switch inside switch, as we define two variables x equals to 1 and y equals to 2, and we switch x, which is variable 1, so that goes to case 1. Now it goes inside the case 1 and displays this x is 1 as this. And now we use one more switch statement, and we switch y, which is 2, so display y equals 2 will be executed, and we come out of this here, and case 2 was not true as case 1 was executed, so we come out here. So this was the report of our first assignment, where we discussed basic MATLAB operations such as basic matrix operations, MATLAB commands to graph, save and read, writing expressions, MATLAB commands for arrays, loop types, and decision making statements. Thank you.